Hello, hello.
Yeah, just a second, Bora. Good morning, everyone, and welcome to Workshop 4 Build with Aiken, part of the Cardano Hackathon Asia IBW Edition 2025, with Hack to Scale as innovation partner. I am Nidhi, your host for today's workshop. In today's session, we'll do a practical deep dive into Aiken, Cardano's developer friendly smart contract language. You will learn how Aiken simplifies contract development and testing, walk through multiple real world use cases, and get hands on with validation logic. By the end of this workshop, you will understand how Aiken streamlines smart contract coding, gain confidence editing, and extending Icon smart contract code for real world applications. We're excited to share that the total prize pool for the hackathon stands at 65,000 USD stable coins distributed across first, second, and third places, plus additional bonus prizes for categories like best meme integration and privacy in action. This is a crucial time. Our hackathon is moving forward to its last stages. Ongoing mentoring and workshops will support you leading up to grand finale in Bangalore on November 29th and 30th. Let me introduce today's expert speaker, Bora Obin from the Cardano Foundation. Bora will guide us through the core concepts, practical demos, and will be available to answer your questions live by the end of this session. Over to you, Bora. Welcome.
Thank you for the introduction. Hello, everyone. My name is Bora. Today, I'll be taking you through the initial first steps into Aiken, and then we'll have the opportunity to go through some of validator examples. I plan to keep the session around 45 minutes to 1 hour, depending on where we land with the time. Of course, we can keep going. I prepared some slides. I'll share my screen. Is my screen visible right now?
Yes.
Right, perfect. So today's session is all about Aiken, the developer-friendly modern smart contract platform for Cardano. It's a bespoke language and tailors to the need of Cardano smart contract developers really well, and has gotten quite popular in the recent times. I think at this point, most of the on-chain logic that was written on Cardano, it has been written with Aiken. So the first step is definitely for anyone trying to learn Aiken is to visit the documentation site. This, let me change my screen and I'll share with you the Aiken documentation site. This is where you land at and where your first steps will take place too. So the moment you enter the documentation, you are presented with 3 buttons over here that will redirect you to different places. The playground, standard library, and the get started. Just to show you a quick glimpse of what they are. I think I have to share my entire screen, sorry. Perfect. Sorry. So right now you should be able to see the playground where you can, this is essentially just the playground as you are used to as developers. This is where you come and experiment with Aiken for the first time. Really likely this is a template smart contract, for example. And this playground is where you can, without your own IDE in a hosted environment, check how Aiken works, try this template validator, see what you would get out of it. But it's nothing more than an introductory step for you, because the Aiken CLI tool will provide you much better results. So the standard library, we'll come to this a bit later. So this is where you land at, right? Getting started. I'm sure you will take your time to go through this after this session as well. But what we are interested right now is how to install Aiken right now. Here in this page in installation, you'll see all commands or all options for your own system. Choose one and install Aiken. We can go ahead with npm, for example. We'll kickstart into development in a few seconds. But before that, I want to give you just so you know your way around. You can see in the web page there is a quick language tour. The Aiken developer documentation is pretty good. Definitely take your time to explore it thoroughly, because it's not only about the on-chain language, but rather gives you the ropes to Cardano as well, because this smart contract language was created for Cardano. It has pretty cool, easy way of developing logic bespoke to Cardano as well. Here you can find the primitive types, operators, how to write functions, the syntactic sugar, how logic gets executed, what are the custom types you will see, and what you can do with Aiken overall. We can take a look at this page so that you have a nice overview before we jump in. So this is how a simple Aiken validator looks like. You can see that with this notation that the following logic is for a validator. So validators are the smart contracts on Cardano. For those who might not have heard that term before, we call them validators because smart contracts work slightly differently on Cardano compared to other blockchain ecosystems. And what essentially a smart contract does on Cardano is to validate the rules of the transaction and check whether that would be allowed or not. So a smart contract's sole responsibility is to check inputs, outputs, or additional data that was provided in a transaction or the validation logic, and then give the green light. So it will be a Boolean answer you get back from it. So if we scroll down a bit more, you can see that now there is a lot more text suddenly at your face, but these are all different script purposes, as we call them. So at this high level overview, you get to see how the syntax would look like, what type of parameters these script purposes specifically would need for you to input into them. So the two of them that you will spend most of your time with is definitely a mint and the spend script purpose, especially the spend, because we'll be diving deeper into Cardano specifics in a second, but just so that you are getting some visual familiarity to what you will see in a second. There's a built-in testing suite in Aiken as well, which is really helpful, which we will see some examples of later on. But all around, what I'm trying to get to at is this. If you start your journey with Aiken, you are in a nicely closed sandbox as a developer, right? Like you have all the tools you need at your service for doing anything on chain, and it's easy to pick up. So we'll start. So go back to my presentation. let's do this. So here you should be able to follow the presentation itself, and you will see my code editor on the side. I hope that's okay. I can zoom into this a bit if this makes any difference. It doesn't. So we visited the documentation site. Is my screen visible, by the way, right now? Is it clear? I do hope so. So what we will be doing today is follow a nicely created, curated educational pathway into doing the firsts in Cardano and utilizing Aiken. It's Aiken project-based learning by Andamir team. So before we dive deep into anything, we have to first get our heads around the concept of UTXOs. I believe you already had workshops in this domain and you might be up to speed, but essentially UTXOs are what sets Cardano apart from many of the other blockchains. It's a way of accounting that is represented in the Cardano ledger, which is originally known from Bitcoin. And Cardano builds upon the idea of UTXOs and extends them. That's why we call them EUTXOs in Cardano. These extensions you will see, and I'll be talking about them a bit more. So how it looks like to get everyone up to speed is the accounting model that you might be used to, where it is you can directly in this global state that is represented in many other blockchains. You have the account model, right? I have 20 points, you have 10 points, and there is no denominators for these points. It's just a ledger, it's just a state of numbers that you change. On Cardano, this activity of transactions are represented not by changing a state on an account, but rather you play around in these small objects called UTXOs and move them around, create rules to spend these UTXOs, and create your business logic around just this natural movement of UTXOs around addresses. It might sound abstract at first, but it is quite, there are quite nice analogies about UTXOs and bills usually. So if you think about it, UTXOs are, instead of saying Ali has 20 tokens, if you think in cash, in money, you could have this 20 as one note, you could have 2 tens, you could have 4 fives, and UTXOs represent this granularity pretty well. So let me go over this. So in UTXOs, when you do a transaction to, let's say you have $20 worth of ADA, or 20 ADA, let's just say, and you want to buy something for 15. So what you do is, instead of saying, I will spend 15 from my account and you will get 15 into your account. So what we are used to in other blockchain ecosystems, on Cardano, you have a UTXO that is valued for 20 ADA. You send that to the intended person or for whatever transaction you were intending to do, and then you expect the change back. And this means that you spend the UTXO and you create new UTXOs that represent the financial transaction clearly. So you will spend your 20 ADA UTXO, you will be left with 5 ADA UTXO, and 15 will be sitting with the intended buyer. Of course, minus the network fees. Let's move ahead. On Cardano, the native assets are also different. They are native to the ledger in a way. I won't be diving deep into too much so that we can get to Aiken faster. I was just trying to cover some of the fundamentals before we do. So this graph is a clean explanation of what I tried to explain just a few minutes ago. In a transaction, you input UTXOs, these objects that carry value, and you create new UTXOs. This is what we are calling as spending outputs. because a UTXO is an acronym for unspent transaction output, and they are atomic operations. If you spend a UTXO, you have to destroy it and create new UTXOs. Let's move on. Yeah, so why functional programming is a nice way to think about Cardano, and it's kind of clear why functional languages are quite well fit for the UTXO blockchains. So I wrote some examples here how to get into the mindset of a Cardano developer in a way, because just like algebraic functions that are written on the left here, a transaction on Cardano also has inputs and outputs and nothing else. This is also how we will be thinking about smart contracts later down the road. So you went through the Aiken docs, you have some of the Cardano fundamentals in your mind, and you're starting. So you first install Aiken, which at this point I hope you did. So this is an Aiken project that I'm in, and what I will show is that if you have Aiken installed already, you can check your version. If you didn't install already, maybe I should have first done that. ACUP is the package manager of Aiken in a way where you can install various different versions of Aiken. And there is also IDE integrations from Aiken, I believe in VS Code, Z, and 2 more different IDEs. If your IDE is supported, definitely do get the extension, because it provides LSP syntax highlighting. It will make your life easier. So now how do we start practically? Let me get my code editor a bit bigger. So we will be following this Aiken project-based learning course, and there is a template repository that you can just kickstart your journey with. I provided the link here. I can also provide that as a link to the chat. So this is where you will be starting, and what you do is clone the repository, create your directory, and get into your environment. So this is what you will be seeing when you land in. This is not the typical new Aiken projects you would see, because it would be an empty project with some folders like the validators folder here and the library folder here, and Aiken lock, Aiken toml, the license file, Bluetooth JSON, and the README. There is additional stuff here already, because there is existing smart contracts that I will be using to demonstrate some stuff to you guys. All right. So at this point, you're in your environment, and you are actually ready to go and start building stuff. The best place to start to try to understand Aiken and what we're trying to do here is maybe to first talk about the tests that you can write in Aiken to check your on-chain logic. So we haven't written any on-chain logic yet, but we will first start by thinking about how we would test them in the first place, and that might bring you up to speed faster. So in this repository, if you write Aiken check in your terminal, I will make this a bit bigger. If you write Aiken check, it will run all the tests in the repository and provide you with a nice report. So this repository has around 102 tests already, which is extensive, for various different examples that you can take a deeper dive into later. but it seems like so Aiken check actually delivered us this result. I will first show you what we got. And it is actually just executing tests in various locations in this repository. And it seems like there is a failing case actually that we can take a look at later. But let's see how a test looks like actually first. Yeah. So I just went into this folder module 102. And here you see a validator written in Aiken that is for the minting script purpose. So its purpose of this script will be about burning or minting a token. And we just see mint, redeemer, policy ID, and transaction fields here. And then just follow that by a true statement and an else. So what you see over here is just an empty transaction, empty smart contract, where there is no logic yet. So there is no conditions for this smart contract to execute on, so it will always succeed. This is why it's named always succeed here. But what you see here is, maybe we'll do a deeper dive into this else thing a bit later. But what I wanted to get at was this test. So when you write your smart contract here, you would have a bunch of logic that you are enforcing transactions to abide by for your business or for your project. And you can directly have your tests below your validators or somewhere else in the repository, of course. But for quick iterations, this is amazing. You write test cases for your validators and you do quick Aiken checks every now and then and quickly iterate on what you're trying to build. What you can do here is, maybe before I do go deeper into it, well, we can take some questions if there are any, or if there is any complaints about the screen size, the visibility, etc. I'm not sure if I will be able to take the questions right now because I don't have them displayed in my UI with the software.
We can think by them at the end, Bora.
All right, so I'll skip over the questions and keep on. All right. So in the slide, which we can also share with you later after this meeting, so you can do it at your own pace, there is a workflow to try for some tests. So it says go to your module 101 under library and open P1 bool. So what you see here is this file has nothing to do with smart contracts. It's just a way to showcase Aiken's testing suite. And there are a bunch of tests that you can see over here. They are just checking for arbitrary logic of operations, right? There is no logic here that's checked. But what we can do here is to show you how this testing suite works. So you can write Aiken check with this flag and then check for a test name, and it will do a string search for you. So before, when I ran Aiken check, it ran 102 tests, gave me that 101 of them are passing, one of them is throwing an error. But what we can do is, let's say that this test is specifically what I'm interested in, and I only want to see that. you can write this, and what you, depending on what you wrote, so I searched for this, it will bring you all results for the tests that has this string. So that's quite cool. Maybe I'll just follow this for a second, and there is also something we can do. So I'll also show you a failing test, and let's see how that looks like. So this this report is quite useful because I just changed the logic here that was previously just telling us that true is not equal to false, right? Or throw an error when this thing can't evaluate to true, right? Any block, any control flow in Aiken is always checking for the Boolean return in each line you can think of. So you write what you see here, just because there's a true here, this test will return true, and that means it will pass. So you write your tests in that logic. So because I changed and made a wrong statement here, this won't return true, and this will mean my test will fail here, as you can see. And the error message is quite good. So it's saying it is equal. So this test is equaling to false, but the expectation was for it to be true. And then you can think of, okay, what do I need to change for this to work? But now this is again working, of course. We can move on to tracing. So tracing is something that you will use for debugging later on. In the presentation, you can see that it is suggesting us to do an Aiken check specifically for variable tracing, and that this test is again throwing an error, and we need to think about why that is the case and how we could solve that. So we are saying that check A is false, and then check B is true, and this is the and operator. So this would mean that both of these statements have to be true in order for this to be true. And here you can see that check A was false. So we are saying false and true, which wouldn't return true, right? It returns a false. But if we were to do this, right? We saw that previously here. This is your negator in a way. So if this was false itself, this is now true. So our statement is true and true. So this should return, yes, it should be a passing test now. And we got to see, yes, this is what I wanted to show here. The trace itself in the second test. Let's see what kind of report back we get from Aiken check if there's a trace in test. So let's get this. So it as you can see, it is passing, and that it's stating that with traces is even. So this trace is just outputting whatever you want to output at that point of execution while you're debugging. So it's kind of your console log if you think about it. So our first smart contracts, these were some fundamental stuff. We can now take a look at some good old smart contracts. So we previously took a look at this always succeed mint validator, and we'll now take a look at this always succeed spend validator here. Let's close the terminal. So there is more meat to the bone in this one example. The always succeed spend validator is the essential bare bones of a spending smart contract. As you can see here, it doesn't have any on-chain logic yet because it's commented out. But let's talk about what we see as a skeleton here. So let me close this. So if you think about it and compare these two, they are pretty similar. So there is a validator word here, keyword here, the name of the validator, the purpose following the name, and then some fields that are specific to the purpose you are trying to write your smart contract in. So in Mint, it was redeemer, a policy ID, and a transaction. In the spending purpose, you would need a datum, a redeemer, a transaction input, and the transaction context itself. So maybe it's important to talk about what these are if they are not clear. So in the most basic sense, a datum is some arbitrary data that you can attach to UTXOs optionally. And the reason why you see option here in the data type here is because it's not obligatory for a datum to be present together with a UTXO. It can be there, or it might not be there, and this is an optional case. So it's either a sum type or a none type. We'll take a look at those. A redeemer is what the person who's trying to interact with the smart contract later on is intending to do in a way. It's the way to express the action you want to take in the smart contract, and we'll get to those. And the input and the transaction you see here, this transaction is the transaction in which this smart contract will later on get executed. So as previously said, smart contracts on Cardano, the validators, are bound by the local state of a transaction. So this is what you might have heard about before, this local state versus global state. In the local state of a transaction, every input, output, or fields, or any context is the correct word here. Any context of the transaction itself is known to you. And you get to build your smart contract logic around the sense that you will have a transaction of which all of the components you know about, and then you can validate some stuff from this transaction in your smart contract. So for example, if I were to have this line here, okay, it's not imported. Right, this should be fine now. So in this line here, we see that, okay, let me, I'll come to the errors and why there is a warning here actually. It is saying expect that there will be an input that we are unlocking from this smart contract's address. And the way you are doing it as logic is you are finding an input, so a specific input from a list of inputs that are present in a transaction. We'll come to that in a second. Maybe we can talk about what the transaction type is like, and I will actually here go back to the Aiken website here, which you will be using quite oftenly. Maybe it's easier for everyone if I just do this. So once you visit Aiken web page, you have the standard library here. And in this standard library, you can also search for types. And a transaction type is where you will find yourself going to quite oftenly when you are checking for documentation. So what you see here is essentially what on-chain smart contracts on Cardano see transactions as. So these are all the fields present in a transaction that you can validate against, check for some logic against, or you are already aware of in the transaction context. So taking a good look at this one is quite important because it gives you the perspectives of things you have access to in a smart contract. So here, what's happening again is we are trying to find one singular input from a list of inputs that we have in this transaction. That's why it is saying tx.inputs and /inputs. So this function takes a list of inputs because a transaction has, let me go back again. A transaction has a list of inputs, and from this list we are only interested in one specific one. So it's this function essentially does that. Why there is a warning here is it is saying that this tx is unknown, and the reason for that is because of this. So if I do this, you will see that this disappeared. If you write this underscore in Aiken, it means that the variable that you wrote this on will be discarded. So discarded as in your on-chain smart contract is not interested in that variable at all because it's not used. But here in our logic, now that we do not have this commented out anymore, we actually do need to access this transaction field in the smart contract. So I can't discard it, and I need that. So now it is complaining about an input, and it doesn't know how to access this because it was discarded previously. So let's also fix that. And now it is saying that this is just an unused variable because in the logic we don't use it. What's something else I can show here is here, let's also do this. So we can still talk about it. So we are essentially pattern matching on some optional datum in the smart contract. And for example, if this logic was here in the smart contract, this would mean that if there is a datum, return true. If there is not a datum, so this is again the type option, right? It can either be some or none. Let's also show that one. Datum. Oh. Maybe I can find it from here. Oh, whatever. So you can also check for these types, of course, here. Just like I searched for transaction before, you can also check for output reference. I tried to find the datum type here, but forgot where it was exactly. But for example, you can also check for the output reference that is specified in the spend smart contract here. And what it is made out of is, so we call it an input here, and an input in Cardano would be the specific UTXO that you're trying to spend from this smart contract. So if we take a step back, we talked about a lot of stuff, but if we dumb it down a bit, what can essentially happen in this template smart contract is this smart contract at the end of the day will govern the rules of spending from a smart contract address, because you see that this is a script purpose for spending. And then the following fields are telling you about what type of interaction will be taking place in a way, if you think about it. There might be a datum in this transaction from the UTXO that you are trying to spend. A redeemer might be present, from the person who is trying to unlock this, who is trying to spend this UTXO. And this field is essentially just the whole transaction itself, where you get to access all the fields and all the information you need to do validation. So I don't want to spend too much time here because our time is quite constrained and it's a lot of stuff to go through. We won't be able to go through a lot of the stuff. So So what we can do is, let's assume that we wrote our smart contract. We will also take a look at the proper smart contract in a bit, with some logic that we are actually trying to enforce. But another command that you need to know is how to compile your smart contract and later on deploy it. Is if you write Aiken build, this compiles your smart contracts to the .ak files under your so the validators you have in this repository will get compiled, and a plutus.json file will be created. This is, in a way, if you are from the Ethereum world, in a way the ABI of the smart contract, the application binary interface. So, right, this is where you have all the information about the smart contract itself. For example, the preamble has some information about the version of Aiken I compiled the smart contract with, the project itself in which we are writing stuff, then data types in the validator, the smart contract compiled code that you can find, and everything that's needed for the smart contract to be executed later on, actually. If we go through some of these stuff, this is aiken.toml. If I didn't talk about it before, is where your compiler version is specified. It gives some more information about the project itself, the dependencies, the repository, etc. Right. So we compiled the smart contract, like every smart contract that's present here. What else can we do? Let's take a look at some testing stuff again, because again, this is where you kind of understand the intricacies of the transactions, and once you understand what you can do with transactions or what you are checking against, you start to get a better feeling about how to think in the mind of a Cardano developer. So this is the transaction data type that we saw previously, and this is also used oftenly, of course, in testing stuff, right? If you're writing, so for example, you have this smart contract here, again, an always succeed smart contract, and then you are testing against it. What you are doing here is, for example, let's take a look at this test. What's happening here is this always succeed validators mint endpoint. Like from the syntax of it, you can read it this way. Mint endpoint is provided with, so you can take a look at what it needs, right, as inputs, a redeemer, policy ID, and a transaction. And you can see there is void, an empty string, and a placeholder here. The placeholder is for the transaction, so a placeholder is available to you if you don't want to recreate this data type entirely. Every time you can use a placeholder. This empty string is for ADA specifically. That would be the policy ID of it, and a void is that it means that there's no data here, so there's no redeemer in this test. And these three inputs are provided to the mint endpoint of this always succeed smart contract. And the test is essentially there for checking if this would be a valid interaction. So if I check for this test, let's do that. Specifically for this test, I can then see if this case is allowed in or enforced against in this smart contract. And you can see that the terminal just tells me that there is one passed. There's some warnings about some syntax, but it's not an error, it's a warning. But this passed. So this was an allowed interaction. If you take a look at another one, for example, this time it is trying to interact with the spend endpoint of the always succeed validator and providing, so this time not three inputs but four, as you can see. So this time the datum, redeemer, input, and the transaction for testing. And there is no so this is saying that in this test there is the transaction that we are checking for does not have a UTXO that we are spending from, which has a datum, or this transaction doesn't have a redeemer. It's void, and this input is what was specified here. And when you run this, you get the idea. I think it would check for this specific case for the smart contract, and if this is allowed. So the way you extend your testing suite is just having a bunch of unit tests, just like this. And then there's also available property-based testing framework baked into Aiken, which is quite interesting too. But let's move away from, for the sake of time, I'll start to go through things a bit faster. What I want to show you is, for example, how here you see a destructured transaction data format in a way. Like if you think about the transaction again, the whole big tree, this time we destructured that and wanted to change a couple of things more granularly so that we can actually check for edge cases in a smart contract, right? Like it's not, you don't want a placeholder transaction every time, but you want to check for specific conditions. So you build your transaction body granularly like this. So you are creating your inputs and outputs and then saying that the rest of the fields of the transaction as a placeholder stays the same, and the inputs and outputs of and the fee of this transaction would be these things that are specified here, and your test is created that way. Let's move on. So we said redeemers a couple of times, and that they are essentially actions for smart contracts that are provided from the user side, for example, when they're interacting with your smart contract or the transaction builder, at least. So here we see the data type of redeemer, right? How does a redeemer look like? This is quite extensive, of course. Usually redeemers don't look like this. But it can have various different actions, as you can see here. Tons of stuff. I won't read all this, but what's interesting here is that how it gets used in the smart contract itself, right? It's so here, if you just read this block, I think it's quite clear suddenly. So this smart contract, for example, let's take a look at how the logic looks like in this one. So we know what this is, spend. These fields are all familiar. Every time there's a spend purpose, we need these fields. All right, so how does the logic look like? Like what does this smart contract enforce? Is there is only this statement here. It is saying it is a pattern match. It's pattern matching on the redeemer that you're providing. And then if the redeemer itself that is provided in this smart contract is a success redeemer, this smart contract should return true. If it is another success case, it should be again true. And if it is anything else, this notation you can think of as the else, it should return false. So this means that if someone provides a redeemer that's outside these two, this would always be failing. This is what essentially the smart contract does. And these tests are there to showcase this. So let's take a look at this. right? So this time we are actually taking a look at the smart contract logic and the tests showing that it is working as intended. So if you see these two tests, you can see that this time in this test, the redeemer provided into this smart contract is of type another success case. And if you remember, it should be returning true if it is provided to the smart contract. So if this test goes through, this should be a passing test because the smart contract allows this. But if I take a look at here, the next redeemer is of type another way to fail, which falls under the bracket of else. So this transaction should be failing on purpose, and we can check for that. Right. Let's take a look. So as you can see, it says passed, but it is actually failing, right? Because this is maybe another nice time to highlight the syntax and how it is used, right? Because there was this exclamation mark here, it negated the fact that this evaluated false and it turned into true. So if I actually remove this here, the negation here, it should be a failing test case. Right? Okay, nice. So this one passed, this one failed, as expected. So moving on to datums. A datum's data type can look something like this. It could be something like this. These are parameters, but you can see that, for example, this redeemer is also slightly different than this type here. These are just parameters that you can also provide to datums or redeemers. And what you use them for is, again, on-chain validation, of course. So if we take a look at this a bit more mature smart contract, let's say, now there is actually some stuff happening in this one. So this is, again, a validator, a smart contract called check datum. Its purpose is to spend a UTXO that is residing under its address and check if it is an allowed one. And the way it would be allowed is if this would evaluate to true for a given transaction. So what's happening here, let's take a look, is there is a redeemer with message. So this let is giving you, it's building upon to the on-chain logic you're going to be enforcing, right? It is saying that there will be a redeemer with a message. And this, if that is the case, if a redeemer with some message field is provided to the smart contract, the message that is provided with the redeemer should match the secret that was written as a parameter to our datum in the smart contract. And if that matches, if the redeemer, let's say that this was a password, right? Like it wouldn't be wise to put your passwords on chain, but still, let's say that it's a weak password that you just put out publicly. And the only way you can spend this UTXO later from the smart contract is if someone takes a look at the datum and sees the secret, and then realizes that they need to provide the same secret in their message in the redeemer. And if that is the case, it is true. So this smart contract allows that thing to be spent, allows that UTXO to be spent. If the message in the redeemer is not matching the datum, what's written in the datum, then it should evaluate to false and it will fail as a smart contract. Here there is more unit tests to check if these would be working, if the logic we wrote out here would be correctly behaving under the circumstances we expected. So for example, let's just take a look at one. So there's a datum and the secret that is written into it is hello world. And if the redeemer's message, as we know from the smart contract, does not match the same secret to message, then it will fail, right? This won't work out, because either the redeemer had to be hello world as well, or the datum had to be good morning Cardano. So let's take a look. So this is passing, right? One check, zero errors. Don't mind the warnings for now. So this is passing because there's a negation. So this is failing now as expected. Let's try to make this work by how we understand the smart contract works as well, right? So we said that the redeemer's message has to be the same as what's written in the datum secret. So if in my test I also swapped the message I wrote as GM good morning Cardano as hello world, because this is in this case, in this test, what was written into the datum, right? And my redeemer's message matches that, the test should evaluate correct or true. So I will run it again, and this time it will work. Yes. So the test is passing because now they are matching. And this is in line with what was written out in the smart contract. I think we are running out of time quite fast. Maybe before I try to show all the intricacies and stuff you can do with Aiken and some of the generic checks that you will be finding yourself to do quite oftenly, let's take a look at a proper smart contract, right? These were all, in a way, demos of small features that I'm trying to highlight, but there is the smart contract is from the mesh team. It's a swap smart contract. It's a basic logic to enable two entities or two persons or two wallets to do an atomic swap without trusting each other. So let's take a look at how our smart contracts looks like. So this swap.ak is the entire smart contract we have, and it's here in this repository. So let's take a look at what's there. So there is a value data type. So this is some data type that was created for some reason, and you can see that it's of pairs. Pairs are like dictionaries. They're a pair of a policy ID and a pair asset name and integer. So the next is the swap datum. The datum in this case, so for this smart contract, the data type expected from the datum would be of type swap datum, which has this structure. So every datum that is legit in the smart contract would need to have three fields in a way. One would be the initiator, who sent probably the UTXO into the smart contract to swap something. And there is a field to provide, there is a field to receive, and these are values, as you can see. So from the context of the smart contract, you can already tell the datum of this datum here is holding the information about who initiated this trade, how much is he providing as value into the trade, and how much is it going to be receiving back, right? It's just like a swap. You give 5 of something to receive 10 of something, and you are and this initiator is just your way of showing the way to the funds, who to send the funds back to if someone swaps with your UTXO. So let's take a look at what happens here. There is a redeemer and you can see that in the smart contract, there's 2 actions that can take place, a cancel or a swap action. And we will see that in the smart contract now. So this smart contract, this validator called swap, its purpose is to spend. The datum type, we talked about it. The redeemer, we talked about it. This input and the transaction, these are at this point known to you. So what happens in here is that you see this word expect. It says expect some datum that is matching this data type. So this datum optional, right? Datum underscore opt. So this means that if I try to spend from this smart contract, I am expecting as a logic to have this datum present in the transaction I'm building. So this datum has to be present in the transaction. Then what happens is we again see the same when redeemer is pattern. And last time we saw this was just branching out the logic into two cases where one is the swap action, one is the cancel action. So you can think of it this way. If someone is trying to cancel this, trying to use the cancel endpoint of the smart contract, the logic that will get executed or is needed is only here. And if they're trying to actually interact with the smart contract and use the swap endpoint, where the actual logic is for the smart contract, this is what it is intended to do, then you need to get through this evaluation, and you have to meet all the conditions to evaluate true so that the smart contract allows you to spend. So taking a look at what happens here, we won't dive deep into all the conditions one by one, but just on a glance, here you can see that we are trying to, again, enforce that there is this input that we are taking from the input list of the transaction and the input from the smart contract address, so the UTXO, and it's usually called own input because if we are trying to spend from the smart contract's address, it is its own input. Then we are defining an own address. So this is if you think about it, this is the address of the smart contract. The own inputs output, and from that output we are getting to the address. We are defining all these things here. Then here, this is critical. So this logic, for example, is quite important. But before we come to this, let's take a look at these two. So is proceed paid and is token unlocked are two expressions, like two statements that are written here, and the swap itself has to abide by the laws written out here. So if this smart contract will allow people to do the swap, so spend the UTXO from the smart contract's address, it will check for these. So the first statement is about is proceed paid, and here you see this weird operator thing. If this is not familiar to you, this is piping, and Aiken documentation has some writings about this, but essentially what happens is you are inputting this variable into this one, and you can, without, maybe I can show that. Yes, so here you can see it better. So instead of writing this function like this, or this call like this, these two are equivalent in logic. So this piping operation evaluates to the same thing as this one. So it's a way to kind of keep track of what's happening in a bit more sophisticated way and a cleaner way. So what it is doing is it is checking for, I don't exactly know what this function does but this, let me see. Yes, this is checking the outputs of this transaction and getting all the value in them, but it is matching the outputs to the owner of the datum, right? Like, because this initiator field is known to us by here, and this initiator is the one who posted that datum or who created this UTXO with the datum there. So it's checking the outputs that are going to the owner of the swap. And this is, for example, this is also, you can see there is definitions to the functions. Most of the time, these utility functions are from a library called Vodka or Cocktail. You will find more about it in the project-based learning that you can follow. And then it is also then checking for some logic regarding if the token is unlocked. In this case, the tokens that should have been unlocked for the swap to take place, you can think of. And if these two evaluated true, if these two statements evaluated true, are smart contract at the end. So this is the whole logic, actually. So all these are checks and definitions, etc. But what the smart contract at the end of the day evaluates is these. So is the proceed paid? Is this true or not? Is token unlocked? Is this true or not? Is only one input from script? Is this true or not? So we have three different, to make it a bit more clear for you all. So here, this is the first thing we are checking, and this needs to be correct for the smart contract to work. And is only one input from script is, for example, what happens here is we are checking for the inputs that are from the script address. And if there is only one, so this notation might be a bit more foreign, but again, this is saying there is exactly one item in this list and in this case, it's a list of inputs. And if there is not only one, and the reason why there is this underscore thing is because we don't really care about which input it is, right? We are just taking a look at if there's only one input from the script. Because if you don't do this check, this might be a bit more advanced at this point, but still, it might make your smart contract be vulnerable to double satisfaction, which could be a topic for another day. But so what I want you to get out of this is that we are just evaluating these three, and outside this logic that we created here, that we're checking in the smart contract, we are just creating data, or we are building bridges from the data available in the transaction to what you want to validate. Let's call it at that. I think for today, this would be more than enough. So I had a long presentation actually, but I think this will be helpful if you are studying at your own pace. And yes, definitely just follow this presentation. There should be links and redirects for you along the way. And I think it will be you will need another additional 1 hour or so after this material, and then you'll have a nice grasp about all the things you can do in Aiken, and have seen some examples at that point. Maybe we can take questions.
Thanks a lot, Bora. We do have some questions. Is how does Aiken structure on-chain validation logic compared with standard Plutus?
Aiken structure on-chain validation logic, that's a mouthful, but I don't know exactly what you mean by this, but so if you mean with Plutus, the Plint, the language, the Haskell language, Haskell subset language for smart contracts, they are from a syntax definitely quite different. Aiken has a more approachable syntax, as many call it, and efficiencies are comparable. Aiken is also at this point quite mature. Plint is, or Plutus as you just called it here, is more for it has quite a lot of extensive features that you can benefit from, but I would definitely recommend Aiken as a starter for many.
Thank you. Another is what are the key primitives in Icon that directly influence script behavior on chain?
Um, Key primitives in Aiken. That's again a really broad question. I'm not quite sure about what the meaning behind it is, but there is nothing specific to Aiken that would change anything on chain on Cardano, right? Like all smart contracts essentially do the same checks in different syntaxes with different trade-offs for performance, etc. So I wouldn't say Aiken has any specifics when it comes to anything on chain. It's just a more approachable modern language with a lot of stuff available to you on day one. Maybe I
Got it.
didn't get the question, but
No worries. We have some pre-submitted questions from the shortlisted participants to us as well, Bora, and I would like to address them as well, which is how does Icon ensures predictable cost behavior during script execution?
well, so this wouldn't be specifically about Aiken, but rather how Cardano works in general and how
Mm-hmm.
transaction fees and the transaction limits work. So once a script is on chain, um, depending on the size of the script, the transaction that executes it will just be met with the same transaction limits as with any other smart contract language, right? The transaction limits are universal, and Aiken has pretty efficient standard library and some built-ins, quite a lot of tools you can use to optimize your smart contracts as well. So if you think about it, it's a pretty nice way to optimize your on-chain logic because you have a lot of tools available to you and a big community. So in a way, passively, you are optimizing your smart contracts just by using Aiken because you have a lot more available to you.
Got it. We have another question, which is when writing a validator, what control flow constructs are available and which are restricted?
Definitely check out the documentation webpage for this. So there's for example, we just talked about the piping operator. So for example, when it comes to the control flow, but the which ones are restrictive? There isn't really much that's restrictive. I'm not sure about the question. Um, there is some opaque types you can write out, etc. But those are I don't think so. That's what you meant with the question. Definitely just check out the standard library and see for yourself what's available to you, because there is quite a lot of functions you don't have to write yourself and are repeated among many smart contracts. So the standard library also provides you a lot of help in that regard.
Okay. Another one is what part of Icon's type system matter most for preventing incorrect contract states?
These are really abstract questions. I was expecting more specific questions about what we did today, but Aiken types, it shares the same types as any other smart contract, right? The best thing about Cardano smart contracts, in my opinion, are many of those are written specifically from a mindset of UTXOs and how to manipulate them. So the type system that's also built around it and the way you write the smart contracts for many of the on-chain logics, not only specifically Icon, is easy to it kind of provides you the framework to work with the on-chain logic, right? For example, in Aiken, the script purposes and how they are presented in the smart contract. For example, the old syntax used to be quite different and much less visible and accessible, let's say, to new people. Now it guides you pretty nicely. I think Aiken is excelling in that regard.
Okay. We have another live question is connecting to Eternal Wallet. Do we have any code blocks?
Yep, that's. I will send some links that can be propagated maybe in the meeting. Definitely check out the developer portal, Cardano developer portal. For most of your questions might get answered also over there. Check out the Aiken documentation, and for some specific pages that will directly help you. So you have to look for in Cardano the CIP30 standard, right? And wallets are behaving accordance to that. I'm looking for the page right now, so I'm rambling a bit. Right. So, for example, I just sent a page from the Mesh SDK. I think some of you might have already had some workshops about it or have seen the Mesh SDK before. This page specifically, if you go there, you see how to integrate using Mesh as CIP30 compliant wallet into your application. And it's just plug and play.
Thank you. Thank you for sharing that, Bora. Now, since we're moving towards the end of the session, thank you all for joining today's workshop. A big thank you to Bora for the invaluable insights that he has shared today. If you have any questions related to the problem statement that you're working on or related to hackathon, please feel free to reach out at support@hack2skill.com. We look forward to seeing your innovation Cardano smart contract projects in the hackathon. Thank you. Thanks a lot, Bora. Thank you, everyone.
Thank you. Have a nice day.